Okay. Greetings, everyone. Today marks a particularly special occasion. We are delighted to welcome Vlad Khononov to engage in a discussion about his book on domain-driven design, a book that has truly resonated with the Apiumhub community. For those of you who might not have had the chance to participate in this year's Global Software Architecture Summit, a quick reminder. Apiumhub is a software development hub that not only organizes the summit, but also makes ongoing contributions to various software communities and initiatives. And during GSCS 23, a substantial number of attendees had the opportunity to delve into Vlad's book. And Vlad has generously agreed to facilitate today's book club session where we can collectively address your questions and explore the aspects of the book that intrigue you the most. Vlad Khononov is a seasoned advocate of domain-driven design and evolutionary architecture. He specializes in assisting companies in understanding their business domains, unwinding monolithic systems, and addressing complex architectural issues. Vlad has been a featured speaker at various industry conferences where he has discussed topics like domain-driven design, microservices, and software architecture as a whole. And beyond his contributions to the field, he plays an active role in co-organizing the domain-driven design Israel and Tel Aviv software architecture meetup groups. It has been a pleasure to have Vlad in GSCS 23 and 22. We already started to organize GSCS 24, and we really hope that Vlad can make it next year. All right, so let's begin our book club session, and please don't hesitate to post any questions in the chat. It's open to everyone, so feel free to ask any questions you might have. Thank you, Vlad.
Thank you so much, Ekaterina. Okay, let's see if we have any questions here. So far, I don't see any. So, you know what? I'll answer a question that I'm usually getting asked. It's once I finish reading the monkey book, what should I do next? So, I assume this is a book club, so you've read it, so it's relevant for you. So, the intention for the monkey book has always been to be a book for a beginner, to provide the least information that's needed for somebody to apply domain-driven design in practice, to turn theory into practice. And yeah, so this book takes you from white belt to, let's say, brown belt. Gets you enough knowledge, just the knowledge you need to start applying this in your day-to-day job. However, if you want to be a black belt domain-driven design practitioner, then you will have to read Von Vernon's Implementing Domain-Driven Design and, of course, Eric Evans's original book, Domain-Driven Design, Tackling Complexity in the Heart of Software. So that's the scale I had in mind when I was writing it. To write something that will be for beginners, to make them productive, to allow them to apply these principles in practice. But if you want to get the black belt, then you have to keep reading. Yep. Oh, I see some familiar faces here in the chat.
Yeah, actually, people who attended the summit. All right, guys, it's time for you to ask any questions related to the book. I know that many of you have read it. And actually, many of you have mentioned that this was your first book on DDD. So take this opportunity and ask Vlad any question you might have.
Yeah, in the meantime, let me think about some other question that I'm being asked regularly about the book. About code samples, some people are asking why I chose to limit the number of code samples in the book. So the goal of the book was to communicate the principles of domain-driven design, to make sure you understand why those principles are there and what problems they're supposed to address. Now, code-wise, I didn't want to provide you any code that you can just copy and paste because that wouldn't fulfill the purpose. Instead, I wanted to focus on the principles, and once you get them, then you can implement those patterns however you want, as long as you follow the principles. And I think we have a question here. Active record to domain model seems an initial transition into domain-driven design. Could be understood as a first approach to domain modeling, or should we start with event storming to focus on domain events? That's a great question. So, first of all, event storming I would do regardless. If you have an opportunity to do event storming, then why not? If it's a new domain for you, for example, you're not familiar with the business domain, maybe even your people from the business are not familiar with it, maybe because it's new for them, or maybe it's just a new solution to a new problem that the company is tackling, then why not do event storm? Storm those domain events, get shared understanding, start building that ubiquitous language about the business domain. And once you've got there, then you will be in a much better position to make the decision of how to model it with an active record or domain model or event source domain model. Now, regarding the transition, I wouldn't say this is the recommended approach, because if let's say you're dealing with a core subdomain with high level of domain complexity or modeling complexity, then it should be just modeled with a domain model. If you start with active record, then you will end up with a big ball of mud pretty quickly. So that's not something that I would advise. On the other hand, there are cases where initially there is no complexity in the business domain. In that case, yeah, it makes total sense to start with active record. However, once you recognize that complexity is starting building up and active record no longer being the pattern that can address that complexity, then you have to refactor to a domain model or event source domain model, whatever fits the case. The sooner you do it, the lower the fine you're going to pay for that technical debt. Now, one thing, there is an advantage of refactoring from active record to domain model versus starting with a domain model. The advantage is during the refactoring, you have way better understanding of the business domain. You're already familiar with it. You have those active record objects. Yeah, they're not encapsulating the business logic. That's not their goal. They're not transactional boundaries. However, you have something, a starting point that you can work with. So you can start by marking all those fields on those active records, making them private. That will force you to move the business logic to corresponding objects. In the next step, you can evaluate the transactional boundaries. And then basically you have a blueprint for your aggregates. So it makes the design easier than compared to starting with a domain model, because, well, again, if you're starting with the domain model, I assume complexity of the business domain. So complexity, uncertainty, and you have to be ready to be wrong about the boundaries. That's something that inherent to that process. You cannot get them right the first time. If you get your transactional boundaries right the first time, then maybe you should have started with active record. Maybe there is no complexity in there. So yeah, there is a lot of iterative design for a domain model. And if you start with active records, if the situation allowed it in the past, then you get that a bit of unfair advantage in designing your aggregates. Okay, I hope that answers your question. If not, let me know. And there is another question from Casper. Are there some things that you redefined in your book referring to Vernon's or Evans's books? Yes, I did. So usually people who are familiar with domain-driven design hear me speak about it and they suddenly, why are you saying core subdomain? Everybody says core domain. I'll tell you the story why I'm using core subdomain rather than core domain as the majority of my colleagues. So in one of companies I used to work at, I had to introduce a lot of people to domain-driven design. Um, and I noticed that if I introduce core domain and generic and supporting subdomains, people assume a hierarchy between them. Like subdomain definitely serves a core domain. Now, that may be true for supporting subdomains, but that's not necessarily true for generic subdomains. Also, the hierarchy is a bit simplistic. If you assume that a generic subdomain serves only one core domain, well, rude awakening, there can be multiple core domains that are going to use those subdomains. And I noticed that in one chapter of Eric Evans's book, he uses the term core subdomain. And I said, okay, that makes so much more sense for me. So I started using it in my training that I was doing at that company, and suddenly people started getting this much quicker. So I said, okay, from now on, core subdomain, that's it. No core domain. There is business domain and subdomains that are the building blocks for that business domain. So that was one thing that I had to sort of refactor in my approach to domain-driven design to make it easier to people to grasp the idea behind that concept of subdomain. Also, domain model that we already mentioned here, that pattern was introduced by Martin Fowler in his Patterns of Enterprise Application Architecture book. It was introduced in a chapter on patterns for modeling business logic, meaning that in that part there were additional chapters. That wasn't the only pattern. Now, in that chapter on domain model, Martin says that, hey, right now there is another book being in the works called Domain-Driven Design, and there you will find a very detailed explanation of how to craft a domain model. And of course, that book was Domain-Driven Design by Eric Evans. However, when it came out, people started thinking about domain model as the only way to do domain-driven design. It became a kind of synonym to domain-driven design, domain model and aggregates and all that stuff. So, in my opinion, that's a bit counterproductive because there are other approaches to modeling business logic. That's why in my book I included other patterns that were also introduced. Some of them were also introduced by Martin Fowler in the same book, to give more options to choose from. And eventually, my opinion is you can have a project without a single aggregate in it. There will be no domain models. There will be, let's say, even active records only, or transaction scripts. But it's still going to be a proper domain-driven design project because there will be ubiquitous language and bounded contexts to protect the integrity of the ubiquitous language. Of ubiquitous languages, sorry. And on the other hand, I've seen tons of examples of projects overflowing with aggregates, with domain events, but they had nothing to do with domain-driven design. And of course, I've been there myself. That's something that a mistake I had to do myself as well. So that's another topic that I kind of refactored in my book. Instead of focusing on domain model, I gave 4 options, 4 ways of modeling business logic, and if I remember correctly, I even added a footnote or something, or I wanted to edit, saying that there can be other ways to model business logic, and there is nothing wrong with using that, as long as you have models, as long as you have ubiquitous languages, bounded context, it's still going to be domain-driven design-based project, even if you don't follow that domain model pattern. Yeah, so that was the second thing that I can think about that I changed. And also, I introduced a chapter on architectural patterns to support those different ways of modeling business logic. Um, what else? And of course, I added a few chapters about the interactions between patterns and principles of domain-driven design and other tools that are popular today, like microservices, event-driven architecture, and data mesh. And I had to do it. That wasn't the case when Eric Evans's original book was published. It was way before microservices craziness, but now it's something that we have to talk about because, again, there is a lot of misconceptions about it. Yep. So these are the things that I changed. I hope that answers your question. And let's read the next one. How do you measure the success of a DDD implementation within a project? Oh, that's a very good question. That's an interesting question. So I would say if we go back to Eric Evans's original book, its subtitle, it says Tackling Complexity in the Heart of Software. In my opinion, that's the goal of domain-driven design, to address complexity in the heart of software. So I will use a definition of complexity from borrowed from Cynefin framework by Dave Snowden, and Dave says that complexity is the relationship between an action and the result of that action. If you know for sure what the result is going to be, that's not complexity. If you can consult somebody about doing something and that somebody can tell you what the outcome is going to be, that's not complexity as well. But if the only way of finding out what the result of an action is going to be is executing that action and then observing the results, then you are dealing with complexity. One caveat, it's not random. If it's random, that's chaos. Hopefully that's not something we're dealing with here in domain of software engineering. So yeah, complexity is the need to conduct those safe experiments to learn the outcome of actions we want to take. So I would say, going back to the question about measuring the success of DDD, I would say the fewer of those experiments you need to conduct to find out the results of changes you want to make, the better the implementation of DDD in that project is. And of course, that touches many aspects that can contribute to complexity. It can come from the first of all, complexity can originate from the problem domain, from the business domain of the system that we are designing. We may not be aware of different rules in that business domain, how it works, how we should implement the business logic, how the system should behave, etc. All these are addressed by formulating a ubiquitous language, a shared understanding with domain experts who do have all that knowledge in the business domain. So the first tool domain-driven design gives us is building that shared understanding with domain experts. And the second one is divide and conquer that complexity. Divide it into bounded context, into different models, optimize each model to address a specific problem, and then it will be easier to tackle that complexity of the business domain because you have more manageable components of a system to work with. And the second source of complexity in software project is of course coming from the solution side, where big ball of mud. Yeah, big ball of mud. I guess that's the poster boy of you have to do the change to know its outcomes, and you're going to be lucky if you learn the outcome immediately, because in many cases you'll get some unexpected surprises in a week or two or a month. Yeah. So anyway, from the solution side, we have those ways of modeling that business logic, of addressing that complexity in the way we're designing the model in the software. And going back to domain model, we have aggregates transactional boundaries, which limit the scope of the context we have to keep in mind when thinking about business logic. An aggregate helps us to limit the scope to only things that particular functionality assumes to be strongly consistent. Everything outside of it is eventually consistent, so we need to focus on what resides within its boundaries. And of course, there are other tools to address complexity on the solution side. These are, of course, bounded contexts and the way we're integrating them. That's kind of a topic not from the DDD book, but from my upcoming book that who knows when it's going to be published. It's on coupling, so another source of complexity is the interactions between components of a system. So in this case, these are bounded contexts, for example. So domain-driven design helps us to limit the knowledge that is shared across bounded context boundaries, and that also makes the system more predictable. So yeah, going back to the original question, I would say that I would measure the success of a DDD implementation by evaluating the complexity that you are facing when working with that system, whether that complexity stems from a problem domain or solution domain. Either way, domain-driven design should help you to tackle those complexities. I hope that answers your question, and I'll go to the next one. FSC asks, sometimes you need to use a domain service inside an aggregate. I want to know if it is recommended to do that, and what is the best way to inject that service in the aggregate. Thank you. Thank you for the question. Really interesting question. And domain services, this is a problematic pattern because aggregate is, of course, a transactional boundary. A database transaction should commit changes only from a single instance of a single aggregate, never multiple of them. Why? Because we want to keep them small, and if we face that situation where we have to change multiple aggregates, then we should take that as an indicator that the aggregate boundaries are suboptimal. Now, domain service, this pattern was originally defined as a stateless implementation of functionality that doesn't fit into a single aggregate, and the focus was on a single aggregate, so people started using domain services whenever they needed to modify states of multiple aggregates, which is kind of problematic because unless you have some infrastructural support, you cannot ensure strong consistency across multiple aggregates, and that the changes are going to be consistently committed. I would never assume that, even if the database allowed that. So I always advise to use domain services for reading data. Let's say you need to read data from multiple aggregates and do some calculations on top of that data. If that's the case, remember that whatever result you're going to get is based on eventually consistent data, because again, multiple aggregates at play. And if you need to use that result of that calculation or output of a domain service and pass it as an input for an operation on an aggregate, then as long as you're okay with that information being eventually consistent, then no problem. Now, how to inject it into an aggregate? I would think about testing, because with aggregates we assume complexity of business logic, so you probably want to be able to test that functionality as conveniently as possible. And once you start injecting domain services, then you have something to mock or fake in your tests. If possible, I would start with an approach where you have your application layer calling the domain service, doing the calculation, and then passing the result to a command on an aggregate. If that's possible, your life is going to be way simpler because you only have to test that command on the aggregate. And all the information it uses is in the input. But if that's not the case, for example, you have to call the domain service from while you're in the middle of that command on an aggregate, because maybe you're getting some data or something like that, then I would just inject that domain service as an argument to that command on an aggregate or aggregate itself. I'm not going to be too dogmatic about it. Either way works. If possible, I would prefer the first option because it makes your life simpler when you need to test the logic, and it also makes it easier to reason about the command of the aggregate. But if not, you can inject it. Just remember to fake it, and remember that all the data you're getting from a domain service is eventually consistent. That's the biggest caveat here. Okay, I hope that answers your question, and let's see the next one. Oh, we have a few questions here. A question about diagram on page 192 in the book. Okay, let me find the book. (192). Here it is. It's the diagram of policy. And now let's read the question itself. Why activate active record and transaction script when it is supported? How much easier is it within a large framework that solves everything for you and is more likely to be known and let you climb better? Oh, so the question is not about event storming. Then I don't know what diagram on page 192 you mean here. Maybe it's a translation or something. Anyway, let me focus again on the question. If you hear my cat screaming, don't worry about him. He's okay. He's just a bit not okay here. So I assume the question is about in the business logic patterns chapter, I give 4 options: transaction script, active record domain model, event source domain model. I assume the question is about why shouldn't I just use one solution to all my subdomains? And some companies are doing that. For example, some companies are using event sourcing for everything. It works for them. I'm happy for them. It didn't work for me. That's why my approach is different. Again, everything is based on my experience. It's not some dogmatic thinking, but something that worked or didn't work for me. Now, the problem I have with one tool solving all problems is first of all, when you introduce new people to your company, it can be quite a steep learning curve to get them into, let's say, event sourcing from their first day. Again, some people are doing that, works for them, I'm happy for them. Didn't work for me. It allowed us, whenever I use that approach, it allows to hire a more diverse group of people. Some people are more comfortable with those advanced approaches like event sourcing, some are not. So using different tools for different problems allows a more flexible hiring of candidates to the company. Next, event sourcing is hard. And yeah, I will use that as an example because that's the other extreme of a transaction script. Event sourcing is hard because it can seem easy that, okay, I'm going to do event storming. I have all my domain events, and that's it. I'm going to turn them into code, and that's it. I'm done here. No. Once you need to change that model, because something changed in your understanding or something changed in the business domain, then suddenly you're going to be in a world of not necessarily pain, but not something pleasant for sure, because evolving an event sourced domain model is not easy. And Greg Young, the guy that formulated the CQRS and event sourcing patterns, he wrote a whole book about migrating event sourced models. So that's for example one of my reasons for using simpler patterns. Next, domain model. Let's say you're working on supporting subdomain, and you say, okay, I'm using domain models everywhere, so I'll use it here as well. But supporting subdomains, they are naturally simpler than core subdomains. There's no complexity there. Their business logic is simple. So even if you try to shoehorn them into a domain model, you will end up with an anemic domain model. An anemic domain model is bad only if you aim to build a domain model. If that's an active record, that's the definition of the pattern, then why not? So one way or another, you will end up with almost the same solution minus all the complexities of crafting the proper transaction boundaries. So that's the reason why I prefer to pick the right tool for a job depending on the complexity of a specific business subdomain. I hope that answers your question. If not, let me know. And next one from Mikhail. Mikhail asks, in your book you talk about some common patterns as, for example, MVC, ports and adapters, or OLAP, OLTP, the way as if it's a part of the DD, although they exist independently. Do you think this exploration is necessary or just my impression? No. I'm not talking about these patterns as if they are part of domain-driven design. At least that wasn't my intent. For example, OLAP and OLTP, they're even located in a part called, what is it called? I don't remember. Relationships to other methodologies and patterns. So it's not part of domain-driven design. MVC, I'm not sure I'm using that, but if you mean ports and adapters / hexagonal / clean architecture / onion architecture, whatever name you prefer, then yeah, I put that in a chapter, architectural patterns, and that chapter explains different architectural patterns that support different ways of modeling business logic. So of course it's not a part of domain-driven design. If you find another pattern that does the job in the same way or easier to implement, go ahead, use it. As I said earlier, there is no dogmatic thinking about these patterns, even patterns for modeling the business logic. I'm just, in the book, I'm just providing the options that I'm using, but there are other patterns that are working for other people, so you can use them as well. Again, as long as you have ubiquitous languages, bounded contexts, models that solve business problems, then it's domain-driven design. And it's not about the number of aggregates you have. And same is true for architectural patterns. It doesn't matter whether you're using ports and adapters or not. If you need it, I had to provide it in the book because I know that whoever is going to read the chapter, for example, whoever is going to read the chapter on domain model and going to implement that, they need to know about ports and adapters. They will need that pattern, because if they try to implement domain model with layered architecture, they're going to be in a world of pain. So I went through that pain myself, and I wanted to save it from the readers. So yeah, I hope that answers your question. Again, domain-driven design for me is the strategic part. The rest, it's a way to implement your models. I'm sure there are other ways. Just these are the ways that are common. These are the ways that I'm familiar with, and this is what I use. So that's why I included in the book. Okay, let's see. Other questions? Might you be looking on the book in PDF page 166? I guess it's related to the diagram from the previous question. Yeah, so I assume that the question is about this diagram. If that's the case, then I answered it. If not, let me know. Okay, sometimes the size of an aggregate might make sense, but practically it doesn't due to platform limitations, for example, not fitting into memory. How is chunking seen as strategy from domain-driven design perspective? That's an interesting question because usually we try to minimize aggregates, and in my recent talk on coupling in software design, I use that quote that says, as small as possible is never a good advice in software design, but then there is this exception, aggregates. For aggregates, it's advisable to go as small as possible, to keep them small, to find those small transaction boundaries, because the larger the aggregate is, the poorer its ability to tackle complexity, the harder it is to commit changes. So I always advise to keep them as small as possible. That was one of the insights from Van Verden's a paper called Principles of Aggregate Design. It was a game changer for me. But yeah, the question is about platform limitations. So I assume that you already minimized the scope of the aggregate boundary as small as possible, so that it contains the minimum information possible that is needed to be strongly consistent. And you have some platform limitation. For example, not fitting into memory. Well, to be honest, I never encountered such situation. I encountered a situation where I was wrong. I had like huge aggregate that couldn't be committed as database transaction. It would cause timeouts and deadlocks on all tables possible, but a thorough analysis of what really needs to be strongly consistent revealed that, hey, it can be simplified. So in this case, I'm afraid I don't have a generic answer, something that can be true in all cases. It depends what is that platform limitation you're talking about, what is the aggregate you have, because it's a hard question. Assuming that your transactional boundary is correct, and you have that amount of information that exceeds platform limitations, then if you split it in half, then suddenly each half is going to be its own transactional boundary. So it can affect consistency of the system. So sorry, I cannot answer that question with a definitive answer. I would say that make sure your transactional boundaries are correct. And if they are, if you absolutely need all that data to be strongly consistent, I would think about maybe reevaluating the platform choices. something like that. Yeah, I would prefer to make a change on that platform side, whereas to risk of generating inconsistent data for the system. Yep, I hope that answers your question. I know it's, sorry, the answer is too generic. Let me know if you have more information about that case. In the meantime, Eric asks, how would you check the email uniqueness without getting dependencies with repositories? Would it be a domain service, the unique constraint, or how? Oh, that's another question about the email uniqueness. So it depends. If you can offload that uniqueness to a database, do it. If you can have a unique index on that table, why not? Do it. Just make sure to catch those exceptions on your repository level and communicate them to the application level in business terms, not in terms of database. Now, let's assume a horror case where it's not possible to use a unique index in a database. So let's say that, let me recall the details. So here's a system that uses DynamoDB to store a customer information. Let's assume it's customer information. And DynamoDB, it's like key value store on steroids. Despite the steroids, it's still key value store, so you cannot query it. It's not a relational database. It's not a real document store. So basically, there are two values. Key is the unique ID of an instance of an aggregate, and then the value was just a JSON with all the information, all the fields from that instance. Now, we didn't want to use email as our unique ID because because the IDs they can't change, and email can change. So yeah, so ID was a unique ID, a global unique ID that was generated, and one of those fields in that JSON with a value was email, and we had to enforce uniqueness. So in that specific case, what we ended up doing is introducing another pattern that I'm really testing my memory now. I think it's called register. But anyway, we called it phone book. Phone book object that was another table in that DynamoDB database. And what it held is its ID, its key, it was the email, and its value was pointing to a ID of the customer with that email. So let's say you're creating a new customer. First step is to go to that phone book table and try to create that record with key being that email and value being a new ID of a new user. Now, with DynamoDB, you can make conditional writes, meaning that create that record only if that key doesn't exist. If it exists, throw me an exception. So, happy scenario, it creates the record. Okay, so we continue using that ID for creating a new customer record in the customers table. A not happy scenario where there is a condition failure, meaning that a key with that specific email already exists in that phone book table. In that case, we know that, hey, it already exists, it belongs to that customer, so there's our unique constraint. There are some edge cases where, for example, you create a record in the phone book table, but not in the customers table, so you have to time them out. Well, I will leave it as an exercise to the reader, and if you have more questions about it, ping me later. And in the meantime, let's see if we have more questions here. Oh, Heavy, I'm sorry if I mispronounced your name. That's, by the way, why I'm not pronouncing all the names, because I'm going to butcher them. So Heavy, I hope I pronounced it correctly. So you're saying modeling a big XML file, for example. That relates to the previous question of aggregate with data being larger than whatever the infrastructure allows. So there are two things I can assume here. Two alternatives I can assume here. The first alternative, you have your aggregate and one of its fields is an XML file. In that case, you can store that XML file independently, and whenever it changes, that generate a new version and hold that pointer to that version on your aggregate, and then your aggregate is going to be much smaller. Or maybe what you mean here is that you persist your aggregate data as a big XML file. And in that case, I don't know. It bothers me how big it is. Uh, um, you know what? I'll tell another story from the same system that I mentioned in the previous question. So I was using the DynamoDB by Amazon when it was just announced. I was doing like beta testing for them, and early on, both DynamoDB and SQS, their service for sending messages, distributed queue, they had a very low limit for the maximum record size, so we ran into that limit. For SQS messages for sure, and if I remember correctly, for DynamoDB as well. Remember, I mentioned that the key was ID of an aggregate and value was JSON for the data of that instance of an aggregate, so we ran into size limitations there. Because earlier on they were really, really low. So first thing we tried was committing them as a compressed byte array to minimize the data. So instead of committing JSON as a string value, we generated in-memory archive, compressed it into zip, and then persisted the byte array. In some cases, it allowed us to compress the data and make it fit those limits. In other cases, it didn't help. So what we did is what I mentioned with the XML earlier. We persisted the state of an aggregate in S3 file, and then updated the DynamoDB saying, hey, your current data is whatever is found in that file on S3. Please don't do it if you can avoid it. It's an exception you have to justify strongly that you really need. But I'm talking here about really, really early days of AWS Cloud, and the size limits were really, really low. I hope that answers your question. If not, give me more information. And in the meantime, we have next question from Apiumhub. Beyond the human mania of categorizing everything, is the distinction between generic and supporting subdomains really necessary? Since supporting can easily become a generic. Oh, that's a good question. That's a good question. So yeah, categorizing things makes it easy to face complexity of the real world, because suddenly you have that mental model that fit things into buckets. Now, supporting subdomain by definition is something that you have to implement in-house. You have to model it yourself, and it doesn't provide you any competitive advantage. Now, generic subdomain, on the other hand, it doesn't provide any competitive advantage as well, but at the same time, it's something that you can, a functionality for which you can use an existing implementation, whether it's off the shelf, something as a service, or open source, or even a well-defined model. There was a book by Martin Fowler. What was it called? Where is it? If I remember correctly, Analysis Patterns. Analysis Patterns. It's a book of, you know what, wait a second. Reusable object models. Here it is. It's quite an old book. It's a pity that there are no newer books on this subject, but it included models for generic subdomains. Models that you can just use and implement yourself. You didn't have to waste your time on modeling them, getting into those business domains. So that's a distinction of generic subdomains and supporting subdomains. For generic, you have an existing solution you can use. It comes from somebody else, not you. Solution for supporting subdomain should come from you. Now, if, as you're saying in the question, if a supporting subdomain can easily become a generic, if that's the case, usually, almost all cases, I would jump on a generic implementation and categorize it as generic instead of supporting. Because the more focus you can attribute to your core subdomains, the better your business is going to be. So if instead of implementing a supporting subdomain which is boring, not interesting, you can focus on core subdomain and just use an existing solution, then why not? So yeah, I think that distinction is useful because it draws a line between things that you have to do yourself versus things you can outsource or use existing solutions for. Also, in terms of complexity, usually supporting subdomains, why do you have to implement them? Because there is no ready-made solution because nobody cares. It's something that is not that complicated. CRUD interfaces, boring stuff. Whereas generic subdomains, usually they do involve some complexity. Managing financial transactions, stuff like that, billing, telephony systems, the poster boy of generic subdomains, identity and access management, all these things. Yeah, so usually for generic subdomains, there is some complexity that somebody wanted to address, to tackle with their solution. Supporting subdomains, they're rather simple, nobody really cares about them, and yeah, you have to implement them yourself, but you can use them as training wheels. Let's say, on that diagram in the book that was mentioned here, there is this decision chart that says if you're in a supporting subdomain, you don't need domain model or event sourcing, or event source domain model. You probably will do much better with transaction script or active record. However, if let's say in your company you have no experience with implementing CQRS and event sourcing, you're supporting subdomain as a training wheels. That's low risk environment for testing those crazy ideas. Because again, the business risk there is going to be much lower than doing those experiments in a core subdomain. Heavy asks if Apiumhub is Christian. Christian, is that you? If that's you, hey. Yeah, okay, let's see. I don't see any other questions here. Well, we still have a few minutes, so yeah, let me think about some question that I'm getting asked regularly about the book. Oh, here there is a question from Heavy. CQRS synchronization synchronous projections. Is it like CDC with Debezium? I'm not familiar with that Debezium thing. Let's see what it is. Open source distributed platform for change data capture. Well, CDC is a great shortcut to CQRS. However, make sure that you can always roll back and erase those projections and regenerate them from scratch. Because sometimes people use CDC as if they are not going to need that. For example, let's say you're not using event sourcing, you have state-based aggregates or active records or whatever, and you have a field called status. And you generate a projection that counts the number of times that status was changed. I'm making stuff up, but you get the point. It's really easy to do it with CDC. You see that, oh, status changed, I'm going to increase the counter. However, you are locked. You cannot erase that projection. You cannot generate it from scratch because you don't have that information in there. So yeah, if you can use CDC for implementing CQRS, by all means do it. It's a great tool. Just be aware of those edge cases. I think in the book I mentioned it like one too many times, that it's crucial to allow regeneration of projections from scratch. Because otherwise you basically cannot make mistakes. You cannot make any mistakes in the implementation of your projections, and you have to think about all the projections you may need in the future right now on the first version, which is basically, yeah, it's pretty realistic requirement, yeah. CQRS. Yeah, I hope that answers your question, and let me think about something else about CQRS. You know what? We have 4 more minutes left, so I will leave you with a Jedi mind trick that I'm not sure that I mentioned in the book. Maybe I did, but it's been a while. So, event sourcing CQRS, these patterns are quite mind shifting, especially for DBAs. You tell them about event sourcing, and then you see their heads explode in different dimensions. So, if you need support in selling those ideas in your company, avoid technical people, go straight to business people, tell them that, hey, we have this way of modeling the information that instead of that state will have all those events. How would you use that? What that would allow you to do in the future? And then they will do the selling for you, basically. Okay, Ekaterina?
Yeah, thank you very much, Vlad. Well, answering Javi's question, if it was Christian, unfortunately not. Christian really wanted to join this book club. Christian is a big fan of Vlad and asked me to organize more initiatives with Vlad because he always has very deep conversations and always happy to chat with Vlad. So he said, do whatever you want, but Vlad should be in JCS 24 for sure. Unfortunately, he couldn't make it today because he's giving actually DDD workshop in Milano in Italy.
Cool.
So unfortunately, he missed this opportunity. But he told me that later on he will definitely watch this book club. It will be published on YouTube. So thank you very much for your time, Vlad. Actually, this is our first book club with an author like you. It was an absolute pleasure. And thank you everyone who participated, who were asking questions. It's nice to see this engagement. Let's keep in touch. We will be announcing other initiatives later on. If you want to receive our communications regarding upcoming events, book clubs, and stuff like this, just subscribe to our Apiumhub newsletter. And normally on a monthly basis, we send a summary of all the initiatives that we organize. And really good book. I enjoyed it. Yeah, in Apiumhub as well. Actually, we dedicated, I think, like 6 months to really like carefully read this book. Every Friday or every second Friday, our team was getting reunited to really deeply analyze everything that Vlad wrote. So thank you for writing this book. And we can't wait to actually start reading your second book, right?
Yeah, I can't wait as well, yeah.
Well, let us know when it will be live, when we can get it, and it will be on our Apiumhub library for sure.
Cool. Thank you so much for the kind words. Thank you so much for your amazing questions. I really enjoyed the session.
Okay. Thanks a lot. Let's keep in touch.
Yeah, be in touch.
Bye-bye.
Thanks so much. Bye bye.